Let's go to page 483 and let's continue with number 31. So you have 2a plus 1, 3a plus 3, 4a plus 5. Okay, so first let's go and find out if this is arithmetic or geometric. Now if you notice this increase kind of gradually, so most likely will be arithmetic. So go and find the common difference. So use this minus that, so give you a plus 2. This minus that will give you a plus 2. So this is your common difference. So now write down the formula. So t of n equal to t1 plus d times n minus 1. So t of n will equal to t1 is 2a plus 1 plus d is a plus 2 times n minus 1. Okay. Now to get a bulk answer, you kind of have to distribute. So you have to kind of distribute this way. So this times will give you n times a plus 2, and then this times will give you minus 1 times a plus 2. Then after that, I'm going to combine these two together and keep this up, keep this one. So you got t of n will equal to n times a plus 2, and this one over here will give you plus 2a plus 1. This one over here will give you minus a minus 2. Okay. Then after you combine these, so t of n will equal to n times a plus 2. Then you combine the like terms, so it will be plus a, and this one would be minus 1. And you can put parentheses around here, and that will give you the book answer. Okay. Okay, let's go to number 33. Okay, it says the sequence of the negative even integers that are multiple of 5. So that means it would be negative 10, negative 20, negative 30, and so forth. Okay. So over here, the d equal to negative 10. Okay. And so these have common difference, so therefore this is arithmetic sequence. And then to find the formula, t of n equal to t1 plus d times, since you use n and 1, so it would be n minus 1. Then you substitute stuff in there. So t of n equal to negative 10 plus negative 10 times n minus 1. So go and work it out. So t of n equal to negative 10. So distribute would be minus 10n. Distribute would be plus 10. And this get cancelled out. So t of n will equal to minus 10n. Okay, let's go to number 35. Okay, so you got 11, 101, 1001, and 10,000 and so forth. Okay, so if you're going to find the common difference, this minus will give you 90, this minus will give you 900. So right away, this is not going to be arithmetic. And geometry, when you divide, it's not going to be the same either. So this one is neither. Now, if it's neither, you have to look for pattern. Okay, so what you do is try to figure out a pattern. And so for this one, notice that it keeps increased by by tenfold, right? So multiply by 10, but there's a 1 that kind of mess things up. So what you need to do, you have to break it into two numbers. So this is equal to 10 plus 1. This is 100 plus 1. So that's a common. So what you do is you try to break it up so that you have common elements. So notice there's a 1 at the end, right? And so this is 1,000 plus 1, and this is 10,000 plus 1. And from here, you can make in the power of 10. So this is 10 to the 1 plus 1. This is 10 to the 2 plus 1. 10 to the 3 plus 1. 10 to the 4 plus 1. Okay? And so here's your T1, T2, T3, T4. So here n equal to 1, right? The n equal to 2, n equal to 3, n equal to 4. So try to look for the relations between the two. Okay, dot, dot, dot. So they can see that t of n would be equal to 10 to the n, right? So what you do is look for common elements. So you got 10 to the some power. Okay, so the things that they have the same, you write it down. So you notice got 10, 10, 10, 10. So you write down the 10. Notice it's plus 1, plus 1, plus 1. You write down plus 1. The part that is varying, that is your n. So notice this part is changing, so that's your n. Okay, and that's it. Okay. So what you do is break it down and look for common elements. When you're looking for pattern, break it down so you can see the common elements. So whatever is common, you write it down. So you got 10, 10, 10, 10. So it's going to be 10 over here. You got plus 1, plus 1, plus 1, plus 1. So it would be plus 1. The part that's changing, that would be your n. So the part is changing is the exponent. So exponent is changing, so that's your n over here. Okay. Okay, let's go to number 37. Okay, number 37, find the position n. So you're looking for n, the arithmetic sequence. So you got 71, 65, 59, and dot, 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 dot. So you're looking for negative 43. So you're looking for this one here. Okay, so you can look for the common difference. So this minus this will give you negative 6. Negative, yeah. Okay, let me double check. Okay. And okay, so you got d equal to negative 6. Okay, so to write down the formula, again, to figure out anything that you miss, anything you want to figure out, you got to use a formula. So t of n equal to t1 plus d times n minus 1, right? So let's go and substitute. So that's your t, that's the n you're looking for, that's your tn. So negative 43 is equal to t1 is 71 plus d is negative 6 times n minus 1. Okay, so again, instead of multiply out, just go and minus 71 on both sides. So you're going to get negative 114 equal to negative 6 times n minus 1 divided by negative 6. So you're going to get 19 equal to n minus 1. So plus 1. So n equal to 20. So this is T20. So this is n equal to 20, and so this is T20. Okay. So anyway, n equal to 20. That would be the answer. Okay, let's go to next one. Okay, it says how many terms are in the sequence? You got 18, 24, 30, dot, 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 dot. 6, 1, 18. So again, looking for n. Okay, so how many numbers in? Okay, so you write down the formula. So t of n equal to t1 plus d times n minus 1. So from here, the d is equal to 6. Right? Okay. So 618 equal to 18 plus 6 times n minus 1. Okay, so you can just substitute it in there. So minus 18. So 600 equal to 6 times n minus 1 divided by 6, divided by 6. So 100 equal to n minus 1. So plus 1 on each side. So 101 equal to n. And that's it. Okay, so there are 101 terms in the sequence.